So, afternoon, everyone. Welcome. Today is our second seminar series in an 11-part series, which is hosted by the Data Science Across Disciplines Research Group in the IFK. So, our speaker today is Luke Machowski. He's a specialist product architect at Synthesis Software Technologies since 2014. He has extensive experience in product development, machine learning, data analytics, and quality assurance. So his current focus is on disrupting the traditional ways of doing regulatory compliance in the field of RegTech. He leads a team helping financial companies comply with reporting regulations, bringing new and novel techniques to a traditionally challenging field. And he uses machine learning specifically to reduce the drudgery of compliance. And in essence, the aim is to actually move the field of RegTech forward. I've actually had personal engagements with Luke on the kind of work that he's doing. And let's just say it's much more tricky than it sounds, to say the least. So he holds a master's degree in engineering in the field of machine intelligence from the University of the Witwatersrand. And he's currently working on his Ph.D. at UJ in Nano Version Control. So Luke, welcome. Thank you so much for being here. And yeah, please take it away.
Thank you so much, Charisse, and I really appreciate this opportunity. So my talk today is about robots of robots, and I hope you'll enjoy listening to the idea. It's something a little bit different, I think, and I had fun putting it together. I hope you enjoy watching it. So. Charisse, thank you for the introduction. I do work at Synthesis. I love working there because they pay me to do what I love the most, which is always wonderful. My master's was in this field, and my PhD, as Charisse mentioned, is Nano Version Control. If you're keen to check it out, you can go to nanovc.io. And the cool part is that what I'm presenting you to you today is really one application of how I can use Nano VC to do something useful. So yeah, if you want to reach out to me, I'd love to get your feedback. I'd love to have more conversations about this stuff. At the end, I'll have a QR code where you can just scan it and sort of get access to this content. So yeah. I'd love to just dive straight in. So we work in interesting times. I'd like to focus in on the timeline for a little bit, so please bear with me. If we think about where we are right now, and then I ask you to go back 2 years to 2019. What I remember about 2019 was there was a heck of a lot of traffic everywhere. The routine that I had, and I'm a software developer, so this will be my routine that I'm sharing with you. Your mileage may vary, but it might be fairly similar. The routine was you wake up, you get in your car, you fight through traffic, you get to the office, you'd have a few boardroom meetings. Eventually, you'd get down to the coding or the stuff you love doing. And then being an engineer, we love breaking hard problems down into smaller pieces. And then you'd collaborate with other people to find a solution and come up with something that solves the problem. Eventually, you'd have some sort of artifact, a product, or a system that you've built that you would then deploy either on premises or onto the cloud. And usually there'd be quite a lot of manual work or hand-holding to pull that off. But eventually you'd have your product delivered to where it needs to go. And this is quite a sustainable process. We could keep doing this all the time. And then 2020 happened. So I'm sure that all of us pulled one of these faces. And I don't think anyone could tell, because we all had to wear one of those. So a few things had to change in our routine. We still needed to wake up. Instead of driving to work, we got quite a bit more time to focus. I must admit, I'm quite grateful for the extra hour and a half that I have to do work, that I don't have to be sitting in traffic. Instead of traffic, we have social distancing. Instead of going to the office, we work from home. Instead of boardroom meetings, we have Zoom calls or Microsoft Teams meetings. We eventually do get to work on the stuff we love to do. And that additional time to focus has been great. And I've also found that somehow I have fewer distractions compared to when I'm at the office. So that's been quite nice from a productivity perspective. However, we can't really collaborate one-on-one anymore. So we've had a lot more virtual calls and these meetings. It's still possible to collaborate, but it's not quite the same. Something that I've found that's surprising, and I like it actually, is the idea of asynchronous meetings. So if we can record the meeting and then I can't watch it, I can't be at the meeting because I'm working with my kids or, stuff's going on. I can watch the meeting later at a time that suits me. And because it's recorded, I found that I can go back and I can rewatch the video. I can slow it down, I can speed it up, I can replay it as many times as I need to, and then I can think through what I want to respond with. And that's been pretty cool, actually. I really like that. And we'll come back to that idea later on in the talk. The next thing is that when we're working from home, it was possible to bring certain bits of your work back home with you, but other things had to stay on premises, or a lot of people got to use the cloud. In South Africa, especially with AWS launching the Cape Town center, it's quite exciting. People have started to embrace the cloud a lot more. And that distance, that separation of where the work actually is interesting. It's another theme that I'll talk to throughout the rest of the presentation. But with that came the opportunity to try and automate stuff. So people got to experiment with automation, and that's the robot. So here's the tie into the topic of the talk. And in the end, we would have our same software product or the system that we're building. And this too is a sustainable process. So what about now? Well, we're going to have to start deciding what are the things that we want to keep and what are the things that we don't want to be doing going forward with our way of working. This is interesting because if we ask ourselves, if I just rated them the way, like the items that I like, this gives me an opportunity to step back and think, well, hang on, why don't I just reassess the whole routine, the whole process? And this is what you get. If I just spread them out a little bit, and if I listed all the things I like and dislike about it, this is what you might land up with. Now, don't worry, we're not going to have to read through all of this. I'm just going to highlight the items that are relevant to our talk today. So the first thing I want to highlight is that I love coding. I've always loved coding. That's the most exciting part of my job. That's something that I love doing, and I've gotten a chance to do more of that now during lockdown and working from home. The next thing is that I'm an engineer at heart. I can't help it. I just love breaking things down to make them simpler and then composing them back together to make something which is complex seem a lot simpler. Finally, we can talk about robots. So I love automating repetitive things. And I love seeing these complex things come together at the touch of a button. Anyone who's done it would have felt that exhilaration when you see that a million things had to work perfectly just to get this final outcome. It's quite a rush. It's quite exhilarating when it when you actually get there. It's not all wonderful though. There's two things that I don't really like about the current automation. I've been doing this for many years, and I've realized that I don't like how fragile some of the automation is. You might get to that point where you've got the system automated, but sometimes a very small change in the system or in the environment can break that automation. And most of all, I don't like how hard it is to get it right. And I'll expand on these two topics. So the rest of my talk is really just about understanding how do we keep the things that I like about automation and fix and replace the things that we don't like. That's it. That's all that my talk is going to focus on today. And I hope you follow the journey. And you might be wondering, okay, so how do we do that? Well, we need people to do what they love to do. For me, it's coding. They need to build prototypes. We also need people to spot the patterns. Patterns are important. Those patterns which are used to build the templates, and you'll see where I'm going with this shortly. So the patterns take the data that build the robot that builds the robot that does the work. That's it. If you followed that, well, then we're done. If that doesn't seem obvious right now, then the rest of the talk, I hope to take you on an explanation of how that does make sense. If there's any engineers in the room, then you might appreciate a system diagram view of that. So if I just shuffle things around a bit and then maybe just relabel a couple of those items, this is what we land up with. So I'll take you through a more practical example of how we get back to this. But what I wanted to share with you today is that we found a way where we can absolutely start seeing those items that we don't like around automation falling away. And that's what I want to share with you. For those that haven't spotted it yet, that's the robot of robots right there. Okay, so that's the title of my talk, and that's where it features. And this will come through in many aspects of the talk. So you might be thinking, yeah, that's lovely, but so what? Well, what I'm finding is that this is the secret to unlocking regenerative production code. Now, that's a really big name for just saying your production code is disposable. That might sound a bit crazy, but that's what it is. If we can regenerate the output, it tends to change a lot of things. In the old way, you really want to keep the production code. It's hard to build. It takes a lot of time and effort to do that. It's very hard to change. If we need to go from one major version of a technology to another, that might involve a rewrite or a lot of effort to achieve that. It's especially painful to lose if you've had some sort of data loss or corruption, and that's all you had, then that's going to sting a little. But the bottom line is it's expensive, not just in terms of money, but in terms of time and people's energy. So this new way of thinking is that we don't care so much about that production code. Yes, it's important to do the job, to give us what we ultimately need, but it's no longer the critical element. So instead, there's three ingredients that we need to keep: the data, the patterns, and the working prototypes. So data is easy to create. We've been doing this for ages. We've got a mature ecosystem. We've even got a whole industry of data scientists where this is their bread and butter. We love this stuff. It's easy-ish to use AI to extract the data, Now, I've been having some really exciting fun using Textract in AWS, so machine learning, where you upload these really dry, boring documents from the regulators and like the JSE, where it's just reams and reams of technical information on how you integrate with them. And by using the machine learning, we can pull out that information where traditionally we'd have to do it manually by hand. We're using AI to extract that data. And then the user experience we design is about judging whether you agree with what the machine came up with, and then allowing them to fix it when it's not quite right. But we find that a huge majority of the time, the machine's right. So that's been really great. So it's not hard to do. It's just we're really starting to get into it, and I'm loving it. The last aspect about that is it's easy to change. Again, our tools and our existing procedures, we know how to do this. We've got excellent processes and machinery, and people know how to deal with data very effectively. The second item that you need to keep are the patterns. So the good news is that patterns are easy to test. If you've ever heard of test-driven development in software, this is an area where it really shines for creating and making sure that patterns continue to work. I must admit, they are hard to write. So it's not something that you can just expect anyone to walk into and do. But the good news is that there are ways that you can practice. And towards the end of my slides, I hope you'll get a new perspective on how we can practice doing that in ways that you might not have expected. The third item to keep would be working prototypes. So this is the part that I love doing. This is where I get to come up with software and code examples of what I'm going to want the final system to look like. These are easy to make. We've got fantastic tooling and IDEs, and there's incredible, tutorials and courses that help you learn how to do that. They're easy to run because they're small. They're easy to test because you don't have the whole system there. You've just got the key ingredients there. And more importantly, because it was easy to create the prototypes, it's also easy to change them. So those are the critical aspects that this new way of working will give us. So what does this do? It converts one really hard problem into 3 simpler problems. That's it. That's all that I'm hoping to share with you today, is that by converting that one really hard problem into 3 simpler problems, it gives us a whole new angle on what I believe is the future of automation in our industry. So, if I go back to our timeline and we look at what's happening now, I'm also quite passionate about what NASA and SpaceX and everyone in the space industry is doing. I love following along. Right now, NASA has already finished in their Artemis program. They've already finished the hot fire tests to their propulsion system. This means that they've got their production rockets that they're going to use to send people to the moon being tested, and that went successfully. You should check out the videos, it's quite spectacular. In 2024, NASA plans to send humans back to the moon again. It's a 3-day journey. It's quite a distance to travel. And they're doing this because they want to send people to Mars. And they need to practice doing it first on the moon to work out how to get it right. And then the moon becomes a springboard to Mars. Now, I don't know exactly when that's going to happen, but their plan is still to do it this century. I want to focus on a different sort of timeline. I'm going to call it the space timeline, space-time. So what I'm showing here is in the red bars indicate the distance to Mars. And then the yellow bars indicate the duration that a signal takes from Earth to reach Mars. So Mars is about 225 million kilometers away from the Earth, depending on where it is in the orbit. And the time it takes for a signal to get there one way is between 5 and 20 minutes. Now that's quite painful. If we look at the moon, and this, by the way, is a logarithmic scale. If I tried to do this linearly, you really wouldn't see these bars at all anymore. That'd be like 1 pixel here on my slide. So I had to do this logarithmically. So the moon is 0.4 million kilometers away, roughly. And the ping time is between 2.4 and 2.7 seconds. It's not too bad. If we look at the space-time distance to the cloud, so if these are my stats, if I ping London, which is about 9,000 kilometers from where I live, that takes about 181 milliseconds. That's pretty decent if you ask me. So we live in fantastic times with bandwidth, thank goodness. If we look at the space-time distance working from home, so I live about 7 kilometers from the office, quite lucky, and that ping time is about 1 millisecond. That's really not bad. And then if we're looking at on-premises, that's actually working on your laptop or on the system. You know, we're talking about, 10 meters or less, or some very tiny distance, and a ping time that's measured in microseconds, even nanoseconds. So what I want to highlight is that the further away our work gets from us, the more important this robots of robots thinking becomes. Again, I'll show you examples that makes this a little bit more real, but I'd like you to remember that this space-time distance is only going to get bigger and bigger as we go into the future. But why stop there? Why don't we look at the deep space timeline? What if we went ahead 100 years to 2121? So now the distance may be 225 billion kilometers away, and that ping time would be 21 hours. Eesh, that's painful. 21 hours just to get a signal over there. Heck, why stop here? Let's just keep going. So let's look ahead 1,000 years to the year 3021. What if we're at 225 trillion kilometers away? That would be a ping time of 868 days. That's nuts. Now, the thing that we need to realize is, okay, here we're constrained by physics. So we can't really do much better than that. But I want to highlight that when we look at the extreme case, this space-time distance becomes quite a significant factor. So, something that's really peculiar and interesting is that it's actually easier to imagine what the world may look like at these time scales than it is to try and predict what it looks like 5 to 10 years ahead. You might not believe me. Let me show you. Because these periods are outside of our lifespans, your guess is as good as mine. So what that means is that we could get an artist or a designer to come up with their best guess of what that might look like. And who's to argue that they're right or wrong? So I'm an eternal optimist, so I would prefer to say, well, what if they're right? Is there anything useful we can learn from that? And this is where I'll ask you to bear with me. We can get an experience of that right now. My hobby is playing games, I'll admit it. And these games, in particular, Factorio and Dyson Sphere program, these are fascinating examples of what it might look like at those T plus 100 and T plus 1,000 year milestones. Please bear with me. Let's see what that might look like. Factorio, step one is quite simple. You crash land on a planet. That's you. That's your ship. That's it. That's all you got. Step 2, you need to start mining things by hand. So you're running around and you're getting coal, and then you're starting to do stuff with that. Anyone who's played Minecraft or any of these games lately, you'll know the drill. And you keep building up your resources and doing stuff. Something really cool that you realize quite early on in the game is that if you build a mining robot and you feed it one piece of coal, and then you hook it up to an inserter robot, what happens is that it first feeds itself to load the fuel, and then it starts feeding the mining robot. So as long as you've got coal in the ground, these robots can go on indefinitely. And that's pretty cool. But what you realize is, actually, I've got to stop doing everything by hand. I've got to build more robots. So that's what you do. Step 3 is you build robots to automate your factory. Step 4 is you build construction and logistics robots to build other robots. And this is because you're aiming for a mega factory. There's just like so much stuff you need to do. And you just need a bigger and bigger factory to achieve that. Here's an example of what it looks like. And I'll let this animation loop a couple of times just so you can get a sense of it. So you're going to lay down prototypes, and they call them blueprints in the game, of what you want built. And those little construction robots, little drones, if you like, they fly around and they go and build what you ask them to build. This other animation shows the logistics robots that are transporting the ingredients, the elements, the supplies to where they need to go. So you're telling the construction robots how and where to build the robots that actually do the work. And that's when you realize, stop building the robots. You got to be building the blueprints. I've been calling them prototypes. It's the same thing. And that's the key where the game changes completely. That's the secret to unlocking the mega factories. If you find this interesting, you must have a look on YouTube at some of the incredibly massive mega factories that people are building. It's mind-boggling. And let's remember, it all started out with one guy on a planet. That's it. So step 5 is you build a spaceship to get off the planet, and that's how you win the game. Simple. If we look at the Dyson Sphere program, I'd never heard of this thing, but it's been around since the 60s. A Dyson Sphere is a hypothetical megastructure that completely encompasses a star and captures a large percentage of its power output. Now, what are we saying there? Imagine we just built a whole bunch of solar panels in a sphere around the star, and then we just started beaming the energy back to where you need it. Now, I think that might help with the ESCOM crisis. But that's quite an intriguing idea, and that's what this game is all about. So what you do is you begin the game and you start doing stuff by hand. As you walk around, you start picking up other resources that are harder and harder to extract. You then start building factories and automation to get that out. And what's cool is you already start seeing those little robots at the very beginning of this game doing the work for you. Those little flying robots build the robots that do the work. So you start to feel that dynamic straight away. And this lets you start expanding across the planet. So what happens is your factory gets bigger and bigger, and you start to outgrow your planet, so you need to find another one. And that's how you go from planet to planet. These are rail guns shooting the satellites to the Dyson Sphere. And that's how you eventually land up with that Dyson Sphere. I'll let this animation play one more time, just so that you can really get a sense of that progression. We start by doing things by hand. We start automating and building machines to do the work. We then get robots to build the robots that do the work. And then we can really multiply from there. Pretty neat idea. This game is really fun to play. I'm not affiliated with them in any way, but it's a damn good game, both of them. So it's an interesting idea. So if we look at that progression back on our space timeline, that's the connection that we can make. Two interesting aspects. This allows us, when we're looking at the space or the place, this approach means that you can leave the planet and the things will regeneratively continue. And with time, you can have asynchronous instructions for the robots of robots to execute when you're not there. Now, if I expand that a little bit, and this is really the crux of the entire talk, so I'm going to spend a little bit of time on this slide. When we look at the space, people can finally leave the project or even the company, and things will continue. This is a very common thing that I've seen, is that you have this production code, this working system, and there's that critical person that like, ooh, I hope they don't leave because then we're all in trouble. So with this approach, we can start to tackle that problem and say, it's okay for you to leave, it's fine. The thing can keep going and it can regenerate because that person designed that ability into the system before they left. That's interesting. Working from home has helped us to understand that robots are robots show us that we can work even if we are not together in the same place. Connection to the games is that two planets, you can work collaboratively. It's like working on two projects or two companies. Can be done. On the time aspect, we realize that people can collaborate at different times, even with delays. It's possible. Working from home, like I mentioned right at the beginning, I love this idea of asynchronous meetings. I was first quite shy of recordings. What I'm doing right now really scared the heck out of me. And it still does, but I'm starting to get better at it. And that's thanks to getting over my fear of recordings that working from home has forced me into. So asynchronous meetings allow me to watch those recordings and repeat them. They allow me to slow them down, and that's really helpful when I'm trying to transcribe or really internalize the message. I can slow it down, type what I'm hearing, and really think about it, but also speed them up. Sometimes I don't need to spend the whole hour there. I can watch it at double speed and then just get to the interesting parts and slow down again. More importantly, I can then send much more meaningful responses once I've done that. I've really enjoyed that. That's been a really great one. So the second part from working from home is that it's shown me that asynchronous collaboration is possible. So the robots of robots thinking shows us that we can do work even when we are not together. So in time. So what I mean by that is think of those two planets where there's a really long ping time between them. You can send those instructions for the robots of robots and they can be executed when it gets there. Somebody who is in that environment can decide, is this appropriate? Do I want to tweak it? Should we change something? I see what they wanted to do. Let me just fix it up because there was a mistake there. That's quite interesting. And the last aspect is that you don't need to send the full production system across the wire. The patterns are small, the prototypes are small. Sending the data may be small if you're just taking a small sample, or it could be large. But the point is that you can decide to send only what is relevant at that time for what's appropriate. Now that's quite interesting. So what? Robots of robots can be converted from that game way of thinking, and it can be applied to software systems, production code. This is the picture that we've come up with. We're seeing that this works. You follow this system diagram, and it's incredible. That same rush of excitement you get while playing Factorio and Dyson Sphere, the Dyson Sphere program. You can experience that on production stuff that you have to do today on your code. The so what is that we're converting one hard problem to 3 simpler problems. Don't know about you, but I'd rather have those simpler problems, to be honest. And just in doing that, it opens up new possibilities. People can move on. It's okay if you leave. We've had some real experiences where COVID makes that reality quite permanent. If you have that reliance on people, we've faced how difficult that can be to deal with. But people moving on to other companies and other projects, that's okay. We've seen that people can be in separate places. They can work at different times. This regenerative approach to the production code means that you can extend that shelf life of your solution because the person who came up with it originally designed it into that way of thinking. We realize that systems can be rolled back. We apply the same data and the same prototypes and the same patterns at a different point in time, and you can roll back. The cool part is that people only need to give feedback occasionally. So when you're sitting halfway across the universe on another planet, you can just watch the stats of what's happening in your other planets and only react when you need to. Or you can strategically choose to send instructions to say, okay, great, we're going to now ramp things up. And that could take days, years, months to get across the system. But you know that when it arrives, that's what's going to kick in. The cool part is that if we have robots that build the robots that do the work, we could say, hang on, please could you build me robots that aren't going to incur the full cost? I'd like to simulate what's going to happen. So we can make lots of mistakes and try things out in a simulated fashion. And then when we're happy, we transition those robots to build the actual robots we're interested in. The last and most interesting point for me is that the robots of robots thinking, that robot is a legacy of that person. Now, in a very intangible world that I find myself in software and in data science, we don't have many tangible things to hold on to. So this robot becomes an extension of that person. That is the legacy that you leave behind. It's a mini version of that person, of what they were thinking, how they were thinking of solving the problems. And that's what we capture with this approach. The cool part is that you can start practicing this today. If you allow yourself to play these games that help you practice to think in terms of these patterns and prototypes, we can be thinking and practicing with future ways of working today, and then you can go and apply it to your own actual work that you're trying to create, your production code. So instead of making coal or little gadgets like we do in the game, the connection is quite simple. We just need to see that as our production software that we're building today, or the data that we're analyzing today. That's it. Thanks very much for listening. If you're interested in more, please give me a shout out. I'd love to talk to anyone about this stuff. I'm really passionate about it. If you scan the QR code, it will take you to a Miro board where I've got this content. I'll be posting any feedback or comments or any additional material that you guys are interested in. You can leave comments there. And that's it. Yeah, that's my talk.
Excellent. Thank you so much. Colleagues, I don't see any questions or raised hands. Does anybody have any questions? If you do, please put it on the Q&A platform or just raise your hand. Luke, I actually have a question for you.
Yes.
So I'm also very intrigued by this idea of a robot, in essence, becomes the legacy of that person, and then that's the means by which you build further robots.
Yes.
But one of the first things that came to mind for me are the issues around a self-driving car, for instance, where if there's an accident, the insurance implications are complicated because who do you now blame? And similarly, if the robot that has built the robots, if those robots make a mistake, how do you blame the robot that is the representation of the legacy person? So for me, in many ways, I feel like a hurdle for us as human beings. In many ways, the reason why we have social hierarchies is because you need somebody who's accountable. So do you have any thoughts or ideas around how you can actually pull the notion of accountability into a system like this?
You know, Cherise, that's a really deep and meaningful question and observation. I haven't really thought about that, but if I took a stab at it now, I suppose what I'm saying, and this is just me reflecting on the message I'm giving. And again, I'm not, I'm not an expert on the ethics and the moral issues here, but the logical conclusion I would imagine from what I'm presenting is that I actually do take a firmer stance on that topic, because if that robot is a legacy of the person, then that responsibility, that accountability, I would argue that I am putting on that person. Now, I don't know how that stacks up when we throw all of the moral and ethical issues.
Yeah.
But without thinking about it too much harder, you've helped me realize that actually I do have a view on that. It's quite simple. That person does have quite a large responsibility because that is an extension of themselves. Now, I don't know what the implications of that statement are, Cherise, and it would be fascinating just to unpack that on its own. I'm sure I'd need to find non-technical people to help me understand that. But I think the debate, no matter what the outcome, we're going to win, right? Something interesting will come out of that discussion. So actually, I realize that I'm not indifferent about it. Actually, I do have a strong view, I suppose, that no, there is a responsibility of what that person put in place or that team put in place. So more than ever, I would say the quality assurance of the data, the patterns and the prototypes becomes more important than ever. One thing I've learned about quality assurance is that we will get it wrong. As an engineer, that's the only guarantee I can give you, is that it will be wrong. And yet the amazing thing with software and engineering is that despite the fact that everything has errors and tolerances, we can still build working systems. And that for me is the magic of it, is that actually I don't need to be perfect. You can take that burden off and the process, the people and the tools. If there's enough feedback, anyone who's studied control theory, will understand that that feedback loop is the key to giving you that. So by making, like here, the 3 simpler problems, I think anyone in data science definitely has an understanding that the data and the patterns can be tested and retested. And that for me is interesting, Cherise. So maybe without this way of thinking, I don't know how you solve that dilemma. But just thinking out loud now, maybe that's the trick. Maybe when you look at it differently, you realize, actually, wait a minute. I don't need the perfect data up front. The process, and like software has proven with the agile approach, which for me as an engineer, I just recognize it as closing the feedback loop, But like, if you have that feedback loop, it's okay to not have your requirements up front, the specs up front. The journey will reveal the requirements. And that's a scary way of thinking and working. But software has proven that it can work. I wouldn't build my house that way. I've had contractors and it's like, well, you got to pay me whatever, 100,000 Rand, and I can't tell you how long it will take and what you're going to land up with, but I'll just try my best. It's such a non-tangible way of understanding the real world. But yet software has shown that, like, well, we live in an abstract world and we need to see it differently. So my proposal, Cherise, and my answer for now is maybe when we look at these 3 aspects, we realize it's okay. Actually, that responsibility is massive. I am accountable if something goes wrong with that self-driving car. But then I'm going to bloody well make sure that I quality assure those 3 key ingredients. Yeah. And I think that's simpler to do than quality assuring the production code that I don't even know is going to be there in the end. Maybe it helps.
Thanks. I actually have another question, which is it's also has to do with kind of these layers that get created. So the question I wanted to ask relates to the notion of the distance that gets developed between the person, in essence, and the product. So I've actually heard stories before around where at NASA, there's certain tools that they developed, and it's now reached a point where people actually don't know, they don't know how to build what was built once upon a time. And so in many ways, my question then comes about is if these layers get developed at some point, if these robots evolve, at what point do we just not have the capacity anymore to actually understand and then take responsibility? I think for me, that's where it also becomes interesting is how do you actually assess, how do we basically hold on to the tech that we create as it evolves and not let it evolve beyond us?
Oh, geez, Charisse, I love your questions, your comments. So I watch this guy, Smarter Every Day, Destin, I think is his name. And, you know, he's been interviewing these guys, and like, what struck me is he said, you know, we've forgotten why the engineers at NASA made certain decisions that they did. Like, we know technically how to land on the moon, but we've forgotten why they made certain choices. And like, some of these reasons are quite arbitrary and quite like stupid, to be frank, or like quite, you know, logistically driven, as in like I ran out of time, or like we had to make a decision, we ran out of budget or something, you know. And but like that understanding is gone now. So I think what you're describing is very real. And I think what's cool, just, you know, the Artemis program, I think they've been a lot more open, you know, with sharing their story, their journey, which is great. I mean, we live in amazing times. They've had to get some of those retired engineers back with their teams now, so that they can like relearn why they made certain trade-offs. And that, like, the question is, and like Destin explores that, like, if we could land the lunar lander automatically on the moon, do we still need to train the pilot how to take manual control? And like, for me, that's a really interesting debate that I don't know the answer to. But like, understanding the why. I think the only way you could tackle that debate would be to understand the whys. You know, so let me just acknowledge, I think you're touching on a very relevant topic that is like, that's what these guys are thinking about now. In terms of the layers, so Charisse, I don't know about you, but I love Git, version control. I enjoy it so much that I'm even exploring it as a PhD topic. And when we look at these 3 ingredients, here we go. Let's go back to the 3 ingredients.
I think maybe just for the audience, while Luke is getting to his slide, this is also pertinent in industry, where there's legacy code there that has existed for quite some time. And people that work in the organization currently don't necessarily know how to manage it. So yeah, please continue, Luke. There's also another question here from Conclejo that we're going to get to.
Perfect, great. So just to wrap that one up, Charisse, I've been working with a lot of data. I've now been working with patterns, data quality and all sorts of other patterns. And I've been working with prototypes. That's just code, but like simple code. And all 3 of those fit elegantly into version control. So the cool part is that I can keep the history, and more importantly, the comments of why I changed stuff. Now, if you don't keep those comments, well, then I can't help you. Sometimes you can piece together, you could imagine, why the heck did they tweak this? And you can make up some reason. I'd still argue that's better than looking at the final output saying, how the heck did we get here? So even without the comments on why between versions, I still think you can reverse engineer the meaning from the commit history. So those three ingredients, to be honest with you, are much simpler to like piece together the insights than the full production code. So, you know, I've been working with lots of systems, and I'm one of those people who don't mind the detail. Actually, I love the detail. But it's hard. It's flippin' hard, Charisse. And, you know, maybe I can do it today, but can somebody else do it tomorrow? Or maybe even can I do it tomorrow? We kind of like stuck with that luck element. You know, on a good day, we'll be able to understand it. On a bad day, then what? Are we saying we're gambling? I think we can do better. So what I've been experiencing now with this way of working is that actually these three problems are really nice to version control. So we can annotate that information in a much simpler manner than trying to do it on the production system, which is usually massive. So that's my answer, is that I think this gives us a different angle or a different tool to tackle that very real challenge of, but why did you make this change? Yeah.
Thanks. So Koklego's question is, what level of tracking exists when robots build robots? So when we as engineers walk away from systems, are we not handing over the quality and freedom to deviate from the original plan if the system sees fit?
So I've got a strong view about this one, and I'm very aware of you know, I watch iRobots too. I've watched Terminator. You know, I'm also watching these things where like we're afraid of what these robots can do. I must admit, I've got although that's still scary, like that's terrifying. I've got a different perspective in terms of what I'm experiencing on the ground. So a quick story, if I could, Katlego, you know, hopefully it makes a bit more sense in terms of how I respond. My feeling is that in first world countries, they're using AI to do really hard things. In my experience, there's this other angle in South Africa. I'm finding that I can use AI to do really dumb, boring, mundane things. And that's also valuable. So there's actually two sides to the AI. Now, for me, I'm not going to solve the whole problem. I don't know how that's going to finally come, you know, to fruition. But I'm finding for these really dumb problems, and especially if you look at this robot of robots as an extension of yourself, let's be clear, this thing can't just do whatever it wants. It does what I told it to do, just like my normal automation does. Actually, it does exactly what I told it to do time and time again. And with unit tests and quality assurance, I can even confirm when it starts doing it differently. We have dependencies that change, environments that change. We can pick it up that like, hey, this is different. This is a different outcome. So with this approach in practice, I'm finding that we still commit the production source code. Of course we do, because that's another way I can detect changes. I commit all of these three ingredients, absolutely. I pay a lot more attention to that and the quality of those things. So I don't see this idea as being a robot that's free to do anything. These guys they just do what we ask them to do. The difference is, what is their objective? Their objective is to build the automation that does, you know, they build the robots that build the robot. They build the robots that do the work for us. That's their job. And it's just that twist in their objective that I think changes a heck of a lot from my experience, you know, working in this manner. These are not like random AI evolving machines. Although on that little orange patterns guy, we're absolutely exploring using genetic algorithms and other evolutionary techniques to augment the human, the person. That's why I got those little cyborg lines there. Is that I think the cool part is AI is fantastic in that space as well. And I'm really enjoying what we're finding there. So if you're keen on that stuff, come join me and, you know, let's figure that part out. But after that, they don't go off and do their own random stuff. And you got the quality assurance and the version control to safeguard against that, or to at least detect that something's different.
Katlego, I've given you permission to talk if you'd like to say something.
Hi, yes, thank you. I just wanted to quickly just give context to my question. So
Please.
I agree with you that there's this fear that comes from the movie world. But what I'm talking about really is I'm a manufacturing engineer and I've worked in the UK and the US. So you're right there that they're using artificial intelligence for more complicated problems, right? So I'm actually in the process of building something for the manufacturing industry. And really my question is coming from, I do want a system to be able to detect patterns that we wouldn't be able to detect as engineers, because we're dealing with so much data over such large spaces. So we typically have to make assumptions, and we definitely have to cut out certain parts of information just to make the problem easier for ourselves, right? So my question really is around, when the machine has all of this different manufacturing data and it sees a pattern that I've never seen as an engineer, because it's running 24 hours. I could never get to that type of detail. In that case, I do want the machine to say, what we're looking at is really not the actual problem. That was a symptom. What the actual problem is X, and then be able to make the decision. But then I'm sort of, I guess what I'm saying is that if you had a decision tree and you had 3 options for the machine, at what level can the machine create a 4th option, an educated 4th option, and then take that option? I don't know if that makes a little more sense.
That's really great. And Katlego, I'd love to chat to you more about this sort of stuff. It sounds fascinating. So I'm going to respond, in terms of the world I know. I'm not in manufacturing, and it sounds really cool what you're doing. But I'm going to respond with sort of my experience of, I think, the same or very similar problem. It's around data quality for the regulatory space in the financial industry. Your data needs to be right. And what I'm finding, so I don't know how to answer your comment and your question perfectly, but let me try with this. I'm finding that the role of people in the loop is critical. And they've got a very simple but specific job for me in the way that I've been working here. Their job is to judge whether they agree with what the machines have discovered or realized. And then if they disagree, then they fix it. Or they give that feedback. That's it. Judge. Now, if you embrace that way of thinking, it actually sorts out a lot. It means, actually, wait a minute. It means that people are not replaced. They're not being replaced, in that job. Actually, they're becoming even more important in that job. And the secondary thing is that, I'm a software developer, so I love building things. It gives me a very specific objective to work towards, and that's to give me the best user experience that you can possibly come up with for that person to judge whether they agree with the machine or not. So, like, practically, what does that mean if I understood your context? It means that you're taking everything you know and have at your disposal in terms of BI and like all of these fantastic tools, and you're configuring it in a way where you can make meaningful judgment calls, which is like, oh, I see a 4th option that you've never considered and your decision tree has come up. Let me drill down. Let me understand. How did you get there? Like, that is so left field. How on earth did this thing find it? And that's where new insight comes from. But notice, it's a decision support objective. It's a judgment user experience. I don't know if that helps you, and I'd love to chat to you more about it. It sounds like a fascinating problem. The cool part, though, is I'm finding that play these games, Katlego. We've got game developers, artists, creative people who've really applied their minds on how best do I get you engaged in that way of thinking. And then once you get into that, you find that you've now rehearsed, you practiced, so that when you get to your problem, and these connections are not obvious, Katlego, in this regulatory world that I love. It's the driest topic you could possibly think of, but the technical challenges and making it simple is really quite challenging, and I love that problem. you can apply that way of thinking then to this harder problem of like, I don't see how it fits in. And maybe that helps you with, so I don't know the answer to your question in your industry, but you've got very little to lose by trying it out. And maybe you'll see that connection. I think your job is to judge in that context whether the machines are right. And then everything around the experience is to help facilitate that process. Is that a reasonable answer?
Yes, no, I think you put it perfectly, because just putting that in words to say it's the role of the person then becomes the judgment and deciding whether this is okay or not. So that really helps me out a lot. I guess what I was imagining is a world where there isn't someone monitoring the system anymore. But then, yeah, of course, I can see how that's not
yeah,
the
and
best.
Katlego, like, I don't know if you've done control theory, like in engineering, but like, you know, for me, that's an open loop system. And, you know, when you have a microphone and you point it at the speakers and it whistles, you know, and everyone goes, you know, like, what do you expect is going to happen? You know, there's like a positive feedback loop and things explode, you know. So as an engineer, I would say, that's probably not a good idea. And it's possible, let me just be clear, if you're precise enough, you can pull it off. But this is the real world. So I wouldn't gamble on that choice. I think we can do better. And that's why I think, yeah, feedback, right? So you design it like, I need that input. But you don't have to do all the work. That's the interesting part.
Yeah, I think you put that perfectly, just that word to say judgment. So, you know, there should be a role that people are doing, you know, that there will be work that's needed, not necessarily just on the maintenance side, but there is some activity that people are doing, and then just putting the word judgment on it helps me out a lot. I would love to talk to you more about this. I'll email you after this. Thank you so much.
My details are there. Please. This would be fascinating. Just if I can share this, Katlego, maybe it helps. You know, I've also been exploring each one of these 3 ingredients on their own. And just on the pattern side, I don't know how it relates to your world, and I'd be fascinated to see if there is a connection. But in the data quality side, specifically around addresses, like where do people live? Like, what's your home address? I'm at 83 Morel Road in Blair Gowrie, and like, here's my address. If you put all of that data into one long line, it's surprisingly difficult to pull that out into street number, street name, city, suburb, postal code. It's one of those things that traditional neural networks are not pretty good at all. I don't even know how to encode them, to be honest. Not from lack of trying. It's just not obvious how that problem fits into neural network design. If anyone knows the answer, please let me know. But what I've found is just using that pattern approach, my team and I, we've been able to do about 3.5 years of manual cleaning in Excel with like Google Maps on the side for like one of the client's data sets, which they by law have to get across to the regulator, right? So it's all above board, POPI, you know, that's part of the law. They have to provide that to make sure you're paying your taxes and stuff. So 3.5 years of manual effort, sitting for 5 hours a day in front of Excel and Google Maps. Now, I've sat next to the data capturers. I don't think any human that I've seen, and in my own experience, I can't sustain more than 5 hours per day at any reasonable quality level. So that's a hell of a lot of work. And we got it done in 2 months. 2 months with this approach, just around the patterns and the quality assurance. And version control is critical. The feedback loops are critical. The unit tests are super critical. Like, that's actually the IP you care about the most. So for what it's worth, just that pattern way of thinking, it's hard to do, but not impossible. But when you look at, you know, you throw the data aspects to it, that multiplier, especially in this world of big data now, is so appealing, because I would trade 2 months of hard work, challenging work, for 3.5 years of drudgery at who knows what quality output level any day. I'd take that bet 1,000,000 times over.
Wow, yes, that's definitely something that I would love to talk to you about as well. The big data aspects. So
Brilliant. I love data. So definitely, yeah. Okay.
Thanks
Thank
so
you.
much.
That was fascinating.
Thank you.
Thanks, Katlego. Okay. Thank you, Luke. I don't think there are any more questions at present. I'm sure Katlego will be bugging you with more of her questions.
Welcome.
I just want to thank you very much for joining us and for presenting on such an interesting topic. And for those of you that would like to join us in April, we will have Professor Enrique Zuazua, who's a chair in applied analysis and also the Alexander von Humboldt professorship holder at the Department of Mathematics in Germany. He specifically focuses on actually quite a wide range of topics, which include PDE, systems control, and machine learning. So I think it will be a very interesting talk for those who are interested. Naturally, the invite will go out as usual, so please keep an eye open. And then I'd just like to thank everybody for attending and enjoy the rest of your day.
The University of Johannesburg, the future reimagined.